Welcome to video 9-1, Reaction Stoichiometry and Steps for Problem Solving. Okay, so chapter 9, we're looking at stoichiometry. Okay, reaction stoichiometries. So some quick review first of all. Okay, change these into moles. Copy these down. Okay, do the problems, come back and check real quick. Okay, so first one, 3.48 grams of hydrogen. First thing, remember hydrogen's formula is H2. So you're going 34.8 grams of H2 times, you want moles of H2, get rid of grams of H2. Okay, and 1 mole is not 1.0079, it is twice that. So it's going to be 2.0158, basically. Okay, and set up the other one. 7.35 times 10 to the 25th molecules of water. Okay, and you want to change this again into moles of H2O. Get rid of molecules, H2O. Okay, and 1 mole has how many molecules in it? Avogadro's number, 6.022 times 10 to the 23rd. Okay, so this bottom one you should come out with, when you do sig figs, 122 moles of H2O. Okay, and the top one, you should come out with 17.3 grams. Whoops, not grams, moles of H2. Okay, don't forget, cancel out your units. You should know what units you end up with when you're done. Okay, now, if you have a balanced chemical equation, remember equations showing you reactions, you can figure out the mass or number of particles or moles, the relationships between what mass of the reactants and what mass of the products are in a chemical reaction, okay, or moles or particle relationships. Okay, so let's say we ran a reaction between XY and QZ. Our products were A, B, and C and D. Okay, our balanced equations have our coefficients A, B, C, and D. Okay, so if, let's say you had moles of XY, you know you can change moles of XY, this substance here, into particles of XY and into grams of XY, right? Okay, now, as long as you have a reaction that is balanced between XY, you also change it into moles of QZ, moles of AB, or moles of CD. In other words, any of these other substances up here. Okay, and how do you get from moles to moles? That's the easiest conversion you're going to have. Okay, the mole ratios just simply come from the coefficients. Okay, in other words, A moles of XY would be equal to B moles of QZ, which would be equal to C moles of AB, which would be equal to D moles of CD. So, because you have equalities, you can change any of these substances into any of these other substances. As long as the units are moles, okay, the equalities and ratios just simply come from the coefficients that are in front of the substance that you see. Okay, so this step right here, to go from moles to moles, is simple. Okay, just use the equality A moles of XY was equal to B moles of QZ. Okay, now, the steps for problem solving. Okay, first of all, determine the products of the reaction. So you're only going to be given the reactants. Use the stuff you learned in the last chapter, figure out the products, and then write out the complete equation. Okay, make sure you balance it. This will give you the equalities, the ratios between moles of any substance in the reaction. Okay, now, problem solving. Read the problem, figure out what you're looking for, what you want. This is basically your answer that you're looking for. Okay, figure out what you're given with. This is where your starting point is. Okay, this is the end point. What you're looking for, what you're starting with. Okay, use dimensional analysis. Change what you're given into what you want. Okay, so let's try a simple problem. How much oxygen is required to burn 20.35 grams of methane? And how many grams of each product are going to be formed? Okay, so first thing we need to know, what is the reaction? Okay, so methane is being burned. So methane, CH4, we're going to burn it. It's a combustion reaction. Add oxygen to it. Okay, you guys should remember from last chapter, if it has carbon when you burn it, you get 2. If it has hydrogen when you burn it, you get H2O. Okay, next thing, balance it. Okay, I got 4 hydrogens there, so I should put 2 there. That'll give me 4. That now gives me 2 plus another 2, 4 oxygens, so put a 2 there. Okay, now we have our balanced equation. What are we looking for? How much oxygen? Okay, so this is basically the end part. Required to burn 20.35 grams of methane. So this is my starting quantity. Okay, notice they don't give you units, but since this is in grams, this should be in grams. Okay, so basically I want to end up at grams of oxygen, and I'm starting with 20.35 grams of CH4. Okay, now if you're confused on how do you get here, okay, let's basically go back and look at this. Okay, let's say this is CH4, this is O2, this is CO2, H2O. I am going from grams of my CH4 to moles of CH4. Then I have to change it into moles of the other substance. So let's say this is our O2. Okay, now once you're at moles, you know you can go to grams of O2. Okay, so grams to moles, change moles of CH4 into moles of O2. You can only change between one substance and a different substance when they're both in moles. Okay, then go grams from moles to grams. Okay, so our first step, we have grams, change it into moles of CH4. Okay, next step, change it into moles of the other substance, moles of O2, then you can change it into grams of O2. Okay, so dimensional analysis, it's all set up for you. Rest of it should be simple. This is the easy part. Okay, you see the arrow means times something over something. Where you're going to has to go on top. Moles of CH4. What you're getting rid of, what you came from, has to go on the bottom. Grams of CH4. Okay, times. Next step. I'm going from moles of CH4 to moles of O2, so that has to go on top. I'm coming from or getting rid of moles of CH4. Okay. Then another arrow, so times. Okay, I'm going to grams of O2, get rid of moles of O2. Okay, so it should cancel out. Okay, 1 mole. How many grams of CH4 weigh? We'll round it off to, let's say it's about 16. Let's see. 16.05, something like that roughly. Okay. Now, the mole to mole part. This is the easiest one. The numbers just come from the coefficients. What's in front of O2? What's in front of O2? 2. That's what goes there. What's in front of CH4? In front of CH4, just 1. Okay. And 1 mole of O2, don't forget it's O2, weighs 32.00. Okay. Rest of it, make sure everything cancels out correctly. Rest of it's pretty simple. Okay. Now, how much of each product is formed afterward? Okay, we are still starting with 20.35 grams of CH4. You have to go to moles of CH4. But from here, you go to the other substances we have, CO2 and H2O. So change that into moles of CO2, and also you change that into moles of the other substance that we have, the H2O. Okay. And then both of these can be changed into grams of CO2 and grams of H2O. Okay, Simple. So did you really learn anything new? Not really. Okay. The only thing you learned that was new was the easiest thing. How do you go from moles to moles? How do you do this conversion, these conversions right there? And that's the simplest it is. And now your review question. Okay, so you are given moles. To change moles of hydrogen to grams of hydrogen, the conversion factor, don't forget this is your fraction, has something over something, conversion factor should have what on top?